Mm, Hello everyone. Continuation of our topic that is implementation levels of the virtualization. We have five levels. In previous video we discussed the five levels. Here we have to discuss in a deep way. First one is instruction set architecture level. The shortcut is ISA, instruction set architecture. In instruction set architecture, virtualization works through an instruction set architecture emulation. This is helpful to run heaps of legacy code which was originally written for different hardware configurations. So these codes can be run on the virtual machine through an instruction set architecture. Here we want to say a binary code that might need additional layers to run can now run on an Zen 86 machine or with some tweaking, and even on Zen 64 machines. Instruction set architecture helps make this is a hardware agnostic virtual machine. So the basic emulation, though it requires an interpreter, this interpreter interprets the source code and it converts to a hardware. It should be readable format for doing processing. What does exactly say instruction set architecture? In the sense, in simple way we discuss, yet the instruction set architecture level, virtualization is performed by emulating a given instruction set architecture by the instruction set architecture of the host machine. It is performed by emulating what they given in ISA. For example, we have seen MIPS binary code. It can run on an Zen 86 based host machine with the help of instruction set architecture emulation. With this approach, we want to say it is possible to run a large amount of legacy binary code it written for various processors on any given new hardware host machine. Okay, so the instruction set emulation leads to virtual instruction set architectures created on any hardware machine. So we want to say some basic simulation method is through code interpretation. Here we want to use an interpreter program interprets the source instructions to target instructions one by one. First one, we have to say the one source instruction may require tens or hundreds of native target instructions to perform its function. Obviously, we want to say this process is relatively slow. So we want to say in instruction set architecture, for better performance, we want to use a dynamic binary translation is to decide. This approach translates the basic blocks of dynamic source instructions to get the target instructions. So the basic blocks can also be extended to program traces or super blocks. We want to increase some translation efficiency. So the instruction set emulation, it requires binary translation and optimization. Finally, a virtual instruction set architecture, it requires by adding a processor, a specific software translation layer to the compiler. It is the main theme of instruction set architecture level. Now we discuss the second level, that is nothing but hardware abstraction level. What the name suggests, this level helps you to perform virtualization at the hardware level. It uses a bare hypervisor for its functioning. Here, so this level helps from the virtual machine and it manages the hardware through virtualization. to enable virtualization of each hardware component such as I/O devices, storage, processors and memory, etc. This way, multiple users can use the same hardware with numerous instances of virtualization at the same time. So IBM had first implemented this on the IBM virtual machine by 370 it back in 1960. It is more usable for cloud-based infrastructure. Thus, Zen hypervisors or by using HAL to run Linux and other operating system on Zen 86 based machines. Nothing more what we want to say exactly now we will discuss here. Hardware level virtualization, it is performed right on top of the bare hardware. So this approach generates a virtual hardware environment for a virtual machine. So the process manages the underlying hardware through virtualization concept. The idea is to virtualize a computer's resources such as its processors, memory, storage devices and input output devices. So the intention, we want to upgrade the hardware utilization rate by using multiple users concurrently. So the idea was implemented in the IBM virtual machine by 370 in the 1960s. So now more recently the Zen hypervisor has been applied to virtualize the Zen 86 based machines to run Linux or other guest operating system applications. Next, the third level is, it's a very important level. It's nothing but operating system level. At the operating system level, the virtualization model creates an abstraction layer between the applications and the operating system. It is like an isolated container on the physical server and operating system that utilizes hardware and software. So each of these containers functions like servers. When the number of users is high and no one is willing to share the hardware, this level of virtualization comes in handy. Here we want to say every user gets their own virtual environment with dedicated virtual hardware resources. This way no conflicts will be arised. What exactly we will discuss operating system level. Abstraction layer between traditional operating system and user applications. Operating system level, the virtualization creates an isolated containers on a single physical server, and the operating system instances to utilize the hardware and software in data centers is nothing but cloud. The containers behave like real servers. So operating system level virtualization is commonly used in creating the virtual hosting environments to allocate the hardware resources among a large number of mutually distrusting users. What the large number of distrusting users to allocate the hardware resources, it is also used to a lesser extent. So in consolidating the server hardware by moving services on separate host into containers or virtual machines, it do one server. Okay, what exactly the virtual machines on one server, to a lesser extent to consolidate the server hardware by moving services on separate host into containers. It is nothing but the concept of operating system level. And coming to the library level, it is nothing but user level application programming interface we want to say. The operating system calls are lengthy and cumbersome, which is why applications opt for application programming interfaces from user level libraries. So the most of the application programming interfaces provided by systems are rather well documented. Hence, the library level virtualization is preferred in such scenarios. The library interfacing virtualization is made possible by application programming interface hooks. These application programming interface hooks control the communication link from the system to the applications. So during some tools available today such as vCUDA and Wine have successfully demonstrated this technique. What exactly we want to say, what does it mean a library level? In that level what we want to do in the sense, so most of the applications use application programming interfaces to exported by user level libraries rather than by using lengthy system calls by the operating system. Since at the past most systems provide well documented application programming interfaces, such an interface becomes another candidate for virtualization. And coming the virtualization with library interfaces, it is possible by controlling the communication link between applications and the rest of a system through application programming interface hooks. So the software tool Wine, here the software tool Wine has implemented this approach. We want to support the Windows applications on top of Linux host. So today some tools available here such as vCUDA and Wine has successfully demonstrated this technique here. So what we want to say, virtualization with library interfaces, it is possibly by controlling the communication link between the applications and the rest of a system through application programming interface hooks. This is nothing the concept of library level. And coming to the fifth level, that is nothing but application level. And coming to the application level virtualization comes handy when you wish to virtualize only an application. It does not virtualize an entire platform or environment. On an operating system, the applications work as one process, hence it is also known as process level virtualization. It is generally useful when running virtual machines with high level languages. Here the application sits on top of the virtualization layer which is above the application program. So the application program is in turn residing in the operating system. So the programs written in high level languages and compiled for an application level virtual machine, it can run fluently. What does it exactly means in the sense, the application level virtualization at the application level virtualizes an application as a virtual machine. Okay, on a traditional operating system an application oftenly runs as a process. Therefore we want to say the application level, one more name we need, process level virtualization. So most popular approach is to deploy high level language virtual machines. In this virtualization layer, it sits as an application program on top of the operating system, and the layer exports an abstraction of a virtual machine that can run programs written and compiled to a particular abstract machine definition. So any program we want to written in the high level language and compiled for the virtual machine, it will be able to run on it. So the Microsoft.NET CLR and Java virtual machines are two good examples of this class of virtual machine. Okay, we want to say the application level virtualization are also known as, we want to say, application isolation, one more name application sandboxing, or one more name we need to call application streaming. Okay, stream in the sense the flow of data. And here the process level involves wrapping the application in a layer that is isolated from the host operating system and other applications. We want to say, so therefore the result in an application that is much easier. We want to distribute and remove from user workstations. An example, we have to take some Landesk application virtualization platform, which deploys some software applications as self-contained and executable files in an isolated environment without requiring the installation system modifications, or we want to say some elevated security privileges. Okay, this is the concept of application level. Okay, thank you ma. Finally, we want to say there are 5 levels of virtualization, implementation levels of virtualization. We have 5 levels. First one is what we want to say. First one, that is nothing but ISA, in the sense instruction set architecture level. Second one is a hardware abstraction level, and third one is operating system level, and fourth one is a library support level, and finally fifth one is application layer. These levels of virtualization is very important concept. Thank you.